Thank you for joining us. Again, my name is Patrick O'Halloran. I am a product specialist with WhereScape. We're here with Ken Graziano, talking about the future of data warehousing and understanding automation levels. So I'm going to do a quick spiel about WhereScape, who we are, how we got to where we are, and then I'm going to talk about, first of all, oddly enough, driving automation, which is kind of the seed, the genesis for what we're talking about today. Then we'll talk about data warehouse automation. And throughout this entire presentation, I'm going to talk about data warehouse. Ken's going to talk about data warehouse. And we really mean any large analytics data system, whether it's a data warehouse, a data mart, a data vault, a data lake house. They're all, in my terms, lumped into data warehouse. I'll give a quick product demonstration just to show off what data warehouse automation looks like, and then we'll have a Q&A at the end. There is a Q&A button at the bottom of the screen. If you have any questions, feel free to type them in. I'm going to be looking here as I'm talking with you. I'm going to be looking here at the Q&A panel. So you'll see my head bouncing back and forth like it's a tennis match. All right, so WhereScape. WhereScape has been around 20 years. We started as a consulting company building data warehouses. We realized we were doing a lot of repetitive manual tasks, so we started building tools for automating that. Those tools became very powerful, and some of our customers started asking if they could buy those tools. And at that point, WhereScape stopped being a consulting company and began as a software company. That was probably about 18 years ago. We have about 1,200 customers around the world in all sorts of verticals, whether it's manufacturing, finance, pharmaceutical, higher education, government, NGO, pretty much everything you can imagine. And the big thing about what we do through our tools, our builder tool and our design tool, is we say 8x developer output. So we not only can produce things, the design, the development, the deployment of a data warehouse much, much faster with fewer errors. So that's one of the nice things about automation is the fewer manual steps you have, the fewer chances you have to introduce errors. Data warehouse automation has 5 main factors. Cost, obviously, if I can get things done faster, that's going to reduce cost, but also the cost of maintenance. People don't think about that very often, or even testing and debugging can greatly be reduced. If I'm generating code, and Kent's generating code or design, whatever it is, you can be sure that with data automation, we're generating it in the same way so that maintenance is much, much easier. Risks, Gartner had a report in 2022 that said that data warehouse projects are the largest, costliest, and riskiest projects that IT departments can take on. There's a lot of reasons for that, but automation definitely helps with that, reducing the risk. Complexity, as you're bringing in data from more sources, as the architectures of data warehouses get more complex, as you're bringing in REST APIs and things, the technical complexity explodes. You've got multiple technologies. We'll see that today in how you bring in data into the data warehouse. Data warehouse automation certainly simplifies that. Urgency, we all saw with COVID, how fast the requirements, the demands, the needs of an organization can change. If I can build things faster, I can respond to the business leaders, the organizational leaders, and give them what they need faster. And then agility, the idea in an agile environment, I can very, very quickly create prototypes. I can sit down with a data analyst. I can give them a working template of what it is they're asking for. They can use the tools they're familiar with, where it's Tableau, Power BI, Yellowfin. They can look at the data and give me immediate feedback. I can add transforms. I can add more calculated columns, whatever it is. In an agile environment, the working prototype is as important as requirements. The idea that a lot of times the analysts don't know what they want when the project starts until they see it. So the idea of rapid prototyping is huge. So you're not here to see me, you're here to see Kent. We've done a couple of webinars with Kent. It's always great to talk with him, both in these webinars as well as preparing for these webinars. It's a lot of fun. Kent's an award-winning author and speaker. Long knowledge of data warehousing and analytic solutions. A Data Vault master, and this has always surprised me, 8th degree black belt in Taekwondo. I think I at one point was a white belt in Taekwondo, so I will not spar with Kent physically, maybe just verbally. And then Kent also had one of the coolest job titles I've heard of when he was at Snowflake, which was Chief Technical Evangelist. He saw WhereScape about 15 years ago for the first time, and he's been a strong advocate of what we've been able to do with data warehouse automation, and that's what we're here to talk about today. Kent, welcome.
Yeah, thanks. Glad to be here. This will be fun.
So I'm going to first talk about, strangely enough, driving automation, and you'll quickly see why this is relevant. But I was reading in an article last summer about how Mercedes-Benz had achieved level 3 of driving automation, the first auto manufacturer to do that. And I first asked myself, there's levels of driving automation. What is level 3? Where are these standards? Who sets these? And being the curious kind of guy I am, I looked it up. It turns out the U.S. National Highway Transportation Safety Board, the NHTSB, has defined 6 levels of automation. And they've got these standards in simplified form, going from no automation all the way to full automation. And the key factor here is driver involvement. Level 0, you probably don't even have an automatic transmission. You're probably operating a choke and a gas pedal and everything else and doing absolutely everything yourself, all the way to level 5, where you're not in control. I don't say you're not in control. You're not doing the direct control. You're sitting in the back seat as a passenger while the full automation takes over. And there's levels in between. So currently, the most advanced automated driving is level 3. Driver is still a necessity, but it's not required to monitor the environment, must be ready to take control of the vehicle at all times without notice. So this got me thinking. We do a lot of times we talk about data warehouse automation, and that, like driving automation, is a term that people kind of think they understand, but when you delve down into it, it's not a simple yes or no kind of thing. And that led me to come up with, how would that apply to data warehouse automation? If there were 6 levels of data warehouse automation, what would they be? And I wrote a blog post about that. That link is down there below on wherescape.com, blog introducing data automation levels. And that goes from no automation all the way to full automation. And the idea is that there are levels of sophistication, levels of built-in intelligence, levels of work that are being done for you in data warehouse automation, just like there is in levels of driving. So as I said, that was the genesis for this conversation today. Kent and I are going to talk about each of these 6 levels of data warehouse automation. Historically, where have we been? Where are we at today? And then level 5 is going to be the interesting one, because that's where we can speculate about if we were a fully automated data warehouse generator, what would it look like and what would the implications of that be? So I'm going to start with level 0, data warehouse automation level 0. And what does that mean? So basically this means you've got no tools whatsoever, either in the design, the development. Kent and I were talking a couple of days ago, and I mentioned that even recently, and I don't mean this as an insult to this person in case they're listening, but just as a matter of fact, I was talking with someone about who's designing a data warehouse on a small level, and I asked them, what tools are they using to design their data warehouse? And they said PowerPoint. So Kent, you had a story about some of the first data warehouses you were building. You were doing pencil and paper.
Oh yeah, yeah. The first data models I ever did were literally hand drawn, on a it wasn't even a whiteboard at the time. I think it was a blackboard. It was an actual blackboard with chalk, and then transferring it to paper, and eventually got into diagramming them using, I think it was actually flow charting elements on an early Mac using McDraw. And it had, of course, circles and triangles and things like that, and arrows, and actually manually drawing it that way, and manually creating text box to put in the names of the objects and the column names and all of that. And of course, those things didn't generate any code at all. I mean, it was a way of communicating what we were doing, and having to start with that. But even as late as, when was that? I said 2008. Even though I'd been, in the Oracle case world, Oracle Designer, Irwin, 3D, all the diagramming tools that existed, I ended up being required to put the ER diagram for the data warehouse into a PowerPoint, because it was going to be presented to managers. And nobody liked the idea of it actually being an ER diagram. So I had to actually just use symbols and shapes and things in PowerPoint. So we actually had the model in Irwin at the time, and I had to actually translate that into PowerPoint by hand. And actually, so that we went backwards from, when we'll get to it, probably like a level 2, we went back to level 0 for the purposes of presenting it to management, who they didn't think would be able to consume it looking at it in an actual ER diagram.
And that's one of the things we talk about at WhereScape. We have in one of our slides what we call the stairway of doom, where in a manual environment where you've got a lot of different tools and a lot of handoffs. So you're talking about going from your ERD tool to PowerPoint, whether it's Word or things like that. And anytime you do that, you've got the potential to introduce mistakes, introduce miscommunication. Um, my background is primarily programming and coding at a pretty technical level. I think I got introduced to analytics processing in the 90s, and I just remember seeing everywhere I went huge diagrams printed out on 8.5 by 11 paper that were then taped, or if they had a large printer, maybe they had big sheets taped up against the wall. There was no way to enforce it. There was no way to understand it other than to go into the architect's room and look at it. There was no other way of communicating it.
Yep.
Yeah, and the other thing that level 0 kind of requires is, back in the olden golden days, I used to understand technology. Back when I was doing coding on Unix, I had a good understanding of what the processor was doing, how hardware was joining, what the kernel was doing, all those things. But nowadays, there's so many different technologies that I don't understand how you can possibly build something from scratch anymore. I'll still hear it though. Okay, this is something that comes up occasionally, and not. I wrote a blog about this as well. Some of the objections about data warehousing are that people say, I want to do everything by hand because I can certainly write code better than some stupid machine. What are your responses to that?
Well, that's a bad idea in general. Yeah, unless you're at a very, very small company. So my son's in college right now, and he's taking intro to business computing. And so they're learning Excel and they're learning Access. And it's like, okay, if you're in that kind of environment, you're a mom and pop shop and you've got a little bit of data, okay, and you've got a kid who just went to university and learned how to do these things, they could go in and code that for you, and you're probably not a huge risk. But if you're any kind of a business that's intending to grow and be successful and to really work to derive value from your data, manually coding things is insane because it just doesn't scale. And like you have mistakes and miscommunication. Well, one of the things with manual coding is syntax errors. When I first got introduced to it was Oracle Case, and it generated PL SQL code back in the early 90s. So this is even before I hit data warehousing. And the thing about that was we never had to worry about syntax errors, right? It generated the code, it had templates, but it was, a PL SQL code generator written by Oracle, who invented PL SQL. WhereScape, when I got introduced to WhereScape, same thing. It's like, yeah, there's no syntax errors in here. If I'm going to generate for Oracle or Teradata or SQL Server, all the various databases that WhereScape supported, it's like I didn't even have to know SQL Server, right? I came from the Oracle world. I could build a SQL Server data warehouse because I could diagram it and then push a button to generate the code, and the code always worked. I did have a SQL Server DBA say one time, well, that's not the way I would have coded it. It's like, I don't care. The question is, does it work? And the answer was yes. And so I didn't have to worry about like unit testing. Unit testing went away. But when you're in manual coding, you got to do unit testing. Even just to get it to, we don't compile SQL code anymore, but you got to run it and not throw an error. So yeah, trying to do stuff manually, that's asking for trouble in the future. Might not be today, but at some point, if you're going to be successful, it's trouble. If you're the employer and you've got one engineer who's going to code everything manually, you need to ask yourself, do I have a backup for that engineer? Because if that guy or gal takes a walk and takes another job, who's going to manage all that code that they wrote and only they understand?
Yeah, you can easily lose a few months there.
Yeah.
An analogy I heard for the first time a couple of weeks ago was, can you build a swimming pool with a shovel? And the answer is yes, but there are much, much, much better ways of doing it.
Exactly.
You mentioned coding. Yeah, I in my background, I would be horribly confused if I wrote some code and it compiled without syntax errors the first time. I would be suspicious. What did I do wrong? And the nice thing about data warehouse automation is that and you'll see it in WhereScape. I'm about to generate hundreds and hundreds of lines of Python code and SQL code, and it all works the first time. I forget if I mentioned this. I don't think I did. As we go through these levels, just kind of give yourself a self-appraisal. Where are you at in your organization? Very, very few people should be at level 0. Unless, as Ken said, it's a very, very small organization. But as we go through these, just kind of give yourself an appraisal of where are you at? What kind of tools do you have? What kind of automation do you have? And that leads us to level 1, which is developer assistance. You've got some tools that are helping you, ERD design tools. Maybe you've got templates you're using. I know in coding, one of the fastest ways, we had a series of transactions that were very, very similar. We would just, my automation thing was global search and replace, which I guess is some form of automation, manual deploying. But all these tools have generally no knowledge about what a data warehouse is. So a lot of the intellectual aspects of it, how do I create facts? How do I create dimensions? How do I tie them together? Are still left up to the developer. I'll give a quick story.
This is where I really started with data warehousing. The first one I ever did was 1995, and we had Oracle Case, which had a modeling tool that ran on OS/2 only as an operating system. So I was able to do the design, diagram the design and review that with the stakeholders. And it even did generate the create table statements, but that's it. Everything else, I basically developed SQL templates myself, just files with the outlines for the load routines and the views for reporting and all of that, so that I could just literally copy the files and then go in, insert the table names and make changes. But that was pretty much it. It was definitely manual. I was thinking about this last night. It's like, how did that thing run? I think it was a batch script that I had to kick off manually once a month in order to because we were doing once a month refreshes on the data warehouse. So I had to manually load the data. It was an Oracle system at the time, so it was SQL loader. So I had to get the files. Somebody transferred the files for me, the extracts from the source system, and I had to manually run SQL loader to get it into the stage tables, and then manually run. I think I kicked off a batch script to run the insert routines to refresh the warehouse. And that was it. It was a manual operation that we ran once a month.
And I think quite a few people can be at this level, at least to some extent, be in this level. It's not like it's clearly everyone's in 0 or 1 or 2 or 3. There's a lot of overlap in what level you're in. But I've seen this where people have 30 copies of code that's all been kind of manually modified. They've got dimensions, the SQL code behind it and code behind it, implemented 30 separate times. And if someone decides later we need to change the functionality of what we're doing, you've got to check out and modify 30 different programs. So there's still some definite drawbacks here. And as I said, the no built-in knowledge of data warehouses. One of our essays had a story about building a type 2 slowly changing dimension in Oracle. And it took them, he said, close to a month just to figure out how to implement it, how to actually implement it. I've got books I show off all the time next to me by Kimball and by Dan Lindstedt. And whether it's dimensional modeling or data vault, I describe those as descriptive. It tells you, here's the entities, here's the properties the entities have, but it doesn't really tell you exactly how to implement it. I don't know if it can. So if you're at level 1, there's a lot of decisions you have to make about how do you create a type 2 slowly changing dimension. And if you get it wrong or decide you need to alter it in the future, there's a lot of work there.
Yeah, and there's a lot of education for the developers and or data engineers and architects that are building it. If you're at a level 1, that knowledge has to be something that they know, that they have inside, that they can figure out how to use the tools that they have to build what you're trying to achieve.
And Ken, I'm sure you've run into this, the idea that even at level 1, level 2, there's a lot of knowledge that's in people's heads.
Yes, of course. Yeah.
And they leave, you have turnover, they get promoted, they move to another department, and all that knowledge leaves with them. We'll see as we get up to the higher levels that a lot of that knowledge is kept as metadata. So now we're starting to get, I wouldn't call it cutting edge yet, but we're starting to get to the point where tools are taking over partial automation. So we're not using templates, or I should say, we're not modifying code directly. But a lot of work is still being done manually. Any exceptions, a lot of things that don't fit the norm are still done manually. But at least the code and script generation is done for you. But you still need a lot of technical knowledge and experience. For example, someone asked about web APIs, REST APIs, and I'll show off that a little later. If you don't have automation or a way of bringing that in, there's a lot of technical knowledge you need to have. And I know that if I had to do some of the things I'm going to do with WhereScape manually, even something as simple as typecasting and conversions going from, say, SQL Server to Snowflake, it would take me quite a while. There's a lot of aspects of knowledge, of technical knowledge. And Kent, maybe you can comment on that. In the last, say, 10 years, how has that changed? How has the expansiveness of the technology involved in data warehousing changed?
Well, like you said, initially, it's even if you got to where you could generate the code, say generate the insert, update statements, and all of that, orchestrating it. There didn't used to be a lot of options for orchestration, for making things run. What order are you going to do these things in? One of the bigger early warehouses I did, we had to run, and we adopted Data Vault. And so we were trying to run a lot of stuff in parallel because the Data Vault model allowed you to do things like that, load things in parallel. And we discovered very quickly that even though logically it would work, the hardware we had didn't support it. So we had to figure out how to orchestrate it, that we had to, load all the hubs first, and then load the satellites, and then load the links, and then load the link sats. And it was a very linear progression, because at a certain level, the CPUs were overloaded, the memory ran out. And so we had to manage all of that. There wasn't anything like what we have today with Snowflake, for example, with the automatic scaling of the compute clusters, right? Where that's not a problem today, because the infrastructure now supports massively parallel processing. If you were on Teradata, back in the early days, you could do the MPP platforms. There was some options there, but then SQL Server and Oracle, there weren't. And so you had to have that knowledge in order to do it, even if you had good code generators. And so that has evolved definitely in the last decade with the advent of cloud computing, for sure, that we're able to do more things, I'll say automatically or automagically, as some people think, than we could, a decade ago.
And as far as source systems go, I know a lot of people are talking about REST APIs now. I don't think those existed a few years ago.
No.
JSON files, XML files. I think one of the most complicated thing I heard about in data warehousing even a few years ago is just incorporating CSVs.
Yes, yeah. And there was some XML early on, but that was only in very specific industries. We had EDI files that was delimited ASCII files, and the loaders for the various databases kind of knew how to handle that, so you didn't have to translate them. But yes, now we've got so much data coming in a JSON format in particular. That one didn't exist back when we started doing data warehousing. That was not something that you loaded. We had the NoSQL movement kind of brought that in, right? That we got the NoSQL and schema on read, and then that turned out to be, that was a lot of operational web-based systems. That's how they were storing the data. And so that's then became sources for enterprise data warehouses, and we had to figure out how to deal with that.
All right. Data automation level 3, conditional automation. So at this point, the tools are starting to understand what data warehouses are. When you try and join, say, a fact table and a dimension, it understands that it needs to join via the circuit key. It makes a lot of assumptions. Things start to become rule-based rather than hard-coded. And then that allows you to modify the rules to generate different kinds of outputs. Rapid prototyping is now a feature. That's a huge thing. As I said earlier, the ability to rapidly develop a prototype. I always say that when you go to a data analyst and ask them, what is it you want? What are the requirements? The answer is always, well, what have you got? A lot of times because they just don't know what they want until they see it. So the idea of getting to this level of automation is I can very, very quickly give them working prototypes. And then you mentioned operations, deployment and documentation are handled automatically. Any comments about what kind of makes this? This is kind of where a lot of companies are at right now, at least.
Yeah. And I think one of the things, one of the evolutions in the automation space was, we went from just being able to diagram the data, so the classic entity relationship diagram, schema diagrams, and diagramming, and then generating tables and views and things like that, to being able to diagram the ETL or ELT process of being able to drag a table onto a palette and then draw a line to connect it to another table and then define on that line what's happening. Are we doing an aggregation? Are we uppercasing everything? Are we trimming character fields? Are we reformatting things? So the T part, right? We got so that it's a lot easier to specify the T without having to actually write code, right? And like you said, you say it's rules based. And so that's what we're talking about with rules, whether it's data type conversions, date math, formulas, things like that, of being able to actually encode those in a more diagrammatic way so that you're not having to go like write all the SQL, write the actual SQL formulas for these things to happen, that the tools have evolved to the point where we can do more drag and drop. And part of that, the evolution happened on the reporting side as well. As people wanted self-service BI, self-service analytics, we had to have interfaces where a business analyst could develop a formula easily and could pick out what they want to do and do what kind of aggregations they want to do. Well, the same things, of course, applied in the ETL and ELT world, data transformations, or as we call them today, data pipelines. What are we doing there? And being able to do that more through a visual GUI interface rather than manually writing a bunch of code to make it happen. We generate it. And now we're into that level again of no syntax errors. The rate of errors in the code has dropped down dramatically. And my argument, I've written about data warehouse automation in general for at least a decade now. And one of the things I learned from the Oracle case world, and Oracle Designer and WhereScape is the more of that you have, he said, the more agile you can be, you can do the rapid prototyping, and you lose all the cycles of just fixing the code to get it to even run the first time, right? Now, granted, all these things, it's rules-based. If you give it a bad rule, well, that's the outcome you're going to get, right? It still is following rules that you're telling it. So if the answer's wrong, well, then you specified something wrong, not necessarily coded something wrong, because the tool is going to generate the code based on your specifications. But now it's a lot easier to iterate that, because if you could get that out, show it to the end users, and they go, yeah, that doesn't look right. How did you get to that? And you can go into your code and look at your lineage and look at the formulas that were used in the tool and go, that's it. That should have been to the second power, not to the third power in that calculation. You change that one little piece, push a button, generate it all again. It drops out, and now you can look at it and it's like, okay, now are the answers right? Yes. Okay, on to the next problem. And so you actually have the ability to debug even faster at this level, but you're debugging really what Dan in the default world, he calls them soft business rules, right? Not hard business rules, because the hard business rules, data type conversions, things like that, people don't tend to mess that stuff up. But the things that are interpretive, that maybe you didn't understand the requirements quite exactly, or the end user didn't articulate their requirements really. Once they saw, oh, I told you that, I shouldn't have said that. We should have done it this way. And then you can go back and you can get a lot more iterative and really be agile because of these things. And again, it's diagram based. You're not having to pour through 20,000 lines of transformation code to find the 2 lines where that rule is embedded, right? And it's so much easier to do that. And that also means it's easier to hand off to, say, to another developer, to another analyst, because we're generating the code. So I don't have to be able to understand and try to interpret what another engineer was thinking when they wrote a particular set of logic in the code. I can look at it at a more abstract level.
Yeah, you mentioned debugging and things and rules-based. It's interesting at this point now, we're getting into automating the design, which is a little different. The rules-based things in WhereScape's 3D, for example, our design tool, can include things like obviously data types, column names, but also things like data profiling. It can go through. So if you're pulling in data from, say, if you're analyzing a source system that's a SQL server or something that's got primary keys and foreign keys, we can understand all those relationships. But if you're pulling it in from flat files or someplace else, you don't have those relationships. Which is a business key? How does a foreign key relate to a primary key? There's actually a rules-based system within WhereScape where it can make its best guess about what those relationships are. And that can save you a lot of time. And those rules are very flexible in that they can include things like data profiling. For example, if a column has more than 10% null values, I don't want to consider it as a foreign key. The rules are very, very flexible. They allow you to do very quickly a lot of work that you would be doing manually. And the other comment I have about this level of automation now is you've got track forward and track back diagrams. You've got data lineage. So when the analysts, every time an analyst presents a report for the first time, whether it's a dashboard or a spreadsheet, anytime they show some numbers, the response is always, where'd these numbers come from? How do you trust these numbers?
Absolutely. Yep.
And the idea with WhereScape, with trackback and data lineage and things, is you can see every single transform that the data went through. Maybe that end result came from 3 different source systems and went through 8 different transforms to get where it is. That's one of the huge advantages of this. It's not just building a data warehouse, but building a data warehouse where you've got confidence, you know what the data is and how it got to where it is.
Well,
as
and
you
you
said,
have the visibility. Yeah, it's visible to I'll say a less technical person. They don't have to be an engineer. Like I said, you don't have to pour through thousands of lines of code to figure out, oh, hey, there's a call to another routine. Now I got to go find that other routine and see what it did, and go look that up and find that in the library. And hopefully it's, it's in a Git library somewhere, but maybe not. Maybe it's in a file system. But yeah, so it's a lot easier. It's all in one place. It's metadata driven. There's a repository, which means it's searchable even.
You also mentioned finding those 2 lines of code you need to change. What's worse is when you need to find those 2 lines of code in 20 different places.
Yes.
And it's been implemented 5 different ways. There's a huge amount of analysis there. That's one of the, when we talk about developer output improvement with data warehouse automation, it's not just producing the code, it's producing very, very maintainable code.
Yes.
That works the first time. All right, we're getting up to level 4, and I would say this is as Mercedes-Benz hit level 3. I would say WhereScape's probably the best data warehouse automation, the most advanced data warehouse automation tool there, from design to development to deployment. I'm a little biased when I say that, but I actually think it's true. And we're starting to get to level 4. I don't think anyone else has gotten here, but there's certainly some things that we've done. Pulling in data from a data catalog. We have a lot of non-analysts now who are building data warehouses. We have an example of a company that builds specialty fabrics, that they came from a previous company where they had 20 people trying to build a data warehouse, and after a year they gave up. 2 of those people went to this new company, and in 9 months they finished a comparable size project. We had a webinar last October with a couple universities and colleges, and it was interesting that one of the larger colleges had a staff of 8 or 10 people. They were actually using undergraduate students to do a lot of their work because of the automation. The other extreme was one woman at a college up in Maine that was doing all the work herself. She was more of an analyst than anything else. And because of data warehouse automation, the technical needs were really, really, really much lower.
Well, and one of the earlier levels you mentioned about there's no knowledge of data warehousing, et cetera, in the earlier level zero, level one, is at this level two, you now can enforce a methodology and approach with knowledge of best practices for architecting a data environment like a data warehouse or a data lake house. And that then allows people who are also, less experienced, you don't have to be a data warehouse expert, because you can follow the template, you can follow the recommended workflow, you can go through the various stages of building out the environment without skipping a step, right? Because it's in the case of WhereScape, for sure, you've embedded 2 decades of best practices into the tool. And you can always argue about, well, is that really the way you should do it? Yeah, you can argue about that, but this is a proven way of doing it. And if you want to do a different way, well, then now you're fighting the tool rather than taking advantage of the tool.
Yeah, I mentioned earlier that some people say they can generate code better than some stupid machine.
No, they
The
can write.
question is,
They say they can write code better.
write code. Yeah.
Yeah.
The question is, can you generate several 100,000 lines of production-ready documented code better than an automated system? There's a good book I've got called The Mythical Man. I'll just hold it quickly. It deals with software engineering primarily, but it's from the 80s. It's still applicable, by a guy named Frederick Brooks. And when he talks about programmer productivity, he's talking about developing operating systems and things like that. He says the productivity of the programmers when they were done was 10 lines of code per day. And that was fully production ready, fully tested, fully documented code. And it's the tested, production ready, documented part that people kind of skip over when they think about how much code they're actually writing. And you'll see that with automation when we go through the demo, that it's documented, it's clean, it works. Can't mention the reduced testing and things. And this last level, level 5, this is the one I'm kind of looking forward to, because no one's here yet. And this is one of those things that, what does this even look like? What does a fully automated data warehouse look like? Is there a data warehouse? So primarily, when Kent and I were talking about this a week or so ago, I said, pretty much you just type in your freeform queries, and this magic machine goes and pulls data from wherever it needs to pull data, and gives you the answer. Now, this is purely on the warehouse side. The analytics side and how machine learning and AI affect that is a completely different subject. But from actually the data warehouse itself, Kent, what's the implication of a fully automated data warehouse where no one's involved in it?
Well, and I'm still not sure how we get to that, because I'm at the Data Universe conference right now, and one of the keynotes this morning was, at some point you still need a human to do, I'll say, a credibility check. Are we really getting what we want? I can see here at this level, if you think about GenAI and ChatGPT, to be able to say, hey, we need to build a historical data warehouse repository, pulling data from our SAP source system, our XYZ, our Salesforce, and our custom home-built inventory management system. Go build it, right? And that's like, okay, so assuming all of that information is there, again, it's all metadata. Is that metadata available? You've got to have all of that. The automation tool has to have access to this information to know where those source systems are, how to connect to those source systems, what the security protocols are for those source systems, and then go through looking at those data catalogs and say, how do these things integrate, right? How are we going to put them together, and then generate the code to pull it from the system, load it into a platform. You'd have to say, I want to build this on Snowflake. I want to build this in Databricks. I want to build this in Oracle, whatever it is. All of that information still has to be there. So, because even with GenAI, it can only do so much based on what it knows. Now, we did do an experiment 2 years, was it 2 years ago? No, it was last year. Yeah, last year at the Data Vault conference, we did actually ask ChatGPT to design a data vault based on the TPCH data set that was shared inside of a Snowflake account. And it actually did a fairly good job. It generated the create table statements, it generated the load statements, all of that. And so I think it's possible we can get there, but it did do some typical errors that we see people do with Data Vault all the time. Like it used the surrogate key, the sequence generated ID from the source system as the business key, which is actually technically not correct. Right? So it didn't go as far enough as to profile the source data to say what's the actual business key. So it didn't know what a business key really was. It assumed a business key just meant the source primary key. So while working on one source system, that would have been fine. If there was two different source systems, it would have had a problem. It wouldn't have gotten the right answer, right? So it's getting there, but I think the implication is really, again, the analyst directing the automation has to still have some knowledge of the data ecosystem that you're dealing with. And the systems themselves have to have enough metadata for the automation to make good decisions. Like you talk about, reverse engineering a schema that doesn't have primary keys and foreign keys in it, right? Based on some rules, it can make some guesses, but a human then still has to kind of look at it and go, yeah, that's the primary key, and those are the right foreign keys, right? So without that metadata there's no way for an AI really to infer it very well, unless it's doing all the data profiling, again, based on some rules. It's got to have some rules, it's got to have some metadata in order for us to really get to that. Your question about is this a data warehouse? Yeah, I think it still is going to meet the definition of a data warehouse, unless you're just going totally federated, totally virtualized, right? Then you're back to the what they used to call a federated or a virtual data warehouse, but the concepts are still there. If we're building an analytics repository that is a historical record of the transactions and everything that's happening in the organization and all the changes over time, and it's meeting, I'll say, Bill Inman's definition of a data warehouse, logically it's still a data warehouse. It just might not be that anybody actually has to physically code it anymore, but somewhere there's still got to be storage, right? And there's still got to be compute. So there's still got to be infrastructure to make all of this work under the covers.
Yeah, I was at TDWI about 2 years ago and as a panelist in a discussion, and one of the questions that came up was, what's the impact of AI on data warehousing? And again, it's two separate areas. One is AI on analytics, and one is AI on actually creating the data warehouse. And I was wrong, I'll admit that, 2 years ago when I said that AI doesn't really have a place in generating a data warehouse, because AI typically requires large amounts of information, and data warehouses all seem to be one-off little projects where everyone's different from every other one. I think 2 years later, I would change my answer to say that there's enough generalities now that we're at the point where Wikipedia was when it first started. It's not a good primary source. People don't quite trust it. There's some information there, but it still needs to be verified. Wikipedia has certainly advanced in the last 10, 15 years, and I expect that AI and generated AI is going to become, people are going to develop more and more confidence in it as they understand what you need to feed into it. We had a separate discussion back in June, I think, about the ethical implications of AI and how you create artificial intelligence.
Yeah, and I think the idea of the free-form queries, I think I'd say that maybe a little different, is free-form questions that, as a business person, that I could ask my AI assistant, I want to know which region we should focus on for rolling out better sales enablement next year. And it should then be able to generate the query and go, okay, based on that question, this is the information I need. Does it already exist, right? Is there a data warehouse, data lakehouse, something already that has that information in that I can just aggregate that up, do the analysis, and then tell the CEO, this is where we should focus? Or it goes and looks and says, yeah, I can't find that data. And so then it has to take that next level to generate the data platform, to find the source. And again, that's back to the how good a data catalog do you already have? Is there lineage? Are there rules already out there that the AI has access to say, I'm asking this question, I know I need this data, the data does not exist, is not persisted anywhere today. How can I go get it? Where can I find that data? Okay, it's in this source and this source and this source, and then kick into the whole, automated design and build of a repository of analytic data in order to answer that one question. And of course, it should be iterative and be able to build off of, say, other repositories that already exist as far as styles. Like if you're a data vault shop, it goes, okay, well, I'm going to design this using a data vault. If it's all big flat tables, it's going to do big flat tables. If it's dimensional star schemas, if it's third normal form, that somewhere there's probably those kinds of decisions that got to get baked in. But if it's learning from its surroundings and its environment for your organization, it's got to, hopefully there's some things that were already built in the past that it can look at as models for how it's going to build I'll say the extension to your existing data platform in order to answer this new query that nobody has asked before.
All right, we're going to do a quick product demo. We've got about a little over 10 minutes left until the top of the hour. A question came up, WhereScape is in which level? Let me just back up quickly and just say that I would say we're between 3 and 4. We definitely cover, I think, everything that's in level 3, and we're starting to cover some things in level 4. So walking into that, let me just give you a very quick demo of data warehouse automation in practice and how automation does a lot of work and really kind of shows you the meat on the bone, so to speak, of when we talk about rapid prototyping and things like that, what it means. So this is our builder tool. This will just take 2 or 3 minutes. Where we build from the bottom up. I'm going to create some individual objects and things and kind of link them together. Our other tool, the design tool, is more of a top-down approach. I describe this as building Legos in our builder tool, and then you assemble the Legos to build whatever data warehouse you want. The other one is more of you build a conceptual model, then a logical model, and you import it into here. But what our builder tool does is we've got data sources here on the left, which could be databases, flat files, ODBC connections, web APIs. And then over here on the far right, we've got our analyst using analytic tools. We're going to load things from our source system into a load table, do any transforms. If we've got a data foundation, we can put that here. This is more suggested than required. I'm going to skip over from my stage table directly into a dimension. So I'm going to create from my SQL Server database, which is my source system. I've got Snowflake running as where I'm creating my data warehouse. I can quickly browse my Northwind database, which is a sample database from Microsoft. Let me move my Zoom controls. And this is my source system. I can create a load table very quickly just by dragging a table from my source system into here. I've got some naming conventions about, first of all, it's converted to uppercase because Snowflake likes uppercase. It knows data type mappings, like those are all configurable, and I can add those there. I will just very quickly build this table and build the script that's going to update it. It's looking at SQL Server. It's understanding the table in SQL Server. It's building DDL for Snowflake. It's doing typecasting conversions. And then it's building and running a script that's going to extract data from SQL Server, load it into a file, compress the file, move that data up into Snowflake storage, and then copy that in there. And it's done. I can look here and see here is my data in a table that's up in Snowflake that didn't exist a minute ago. If you're curious, we talked about generating code and code working the first time. Here's 565 lines of Python code that's fully debugged, fully production ready. It's got all the error checking and everything else you have in here. It pulls data out of SQL Server, puts it into a file, copies it up to Snowflake storage, and then moves that from Snowflake storage into my table. That's how fast I can create a load table. I can create a stage table similarly. Let me browse my data warehouse and grab this, drag this over here, and I can create a stage table. Again, this is where I would be doing transforms. There's a lot of options here that I'm skipping over. You're seeing the tip of the iceberg. I'm trying to get this done and take up as little of your time as possible and just give you an idea of what data warehouse automation can do. So identify the business key. I click OK. Same thing, it's going to generate DDL. All the work that's taking place now is taking place as NoSQL code in Snowflake. I haven't added any transforms, but if I wanted to, I can go at the column level and add any transforms I wanted. I could pretty much add in here any SQL expression that Snowflake will accept, but then I will create my dimension off of that. So again, I set my context to dimensions. I refresh here. I look at my stage table. Here's my stage customers. One of the things that's a little bit different about dimensions, if you remember dimensional modeling, how do you handle changed records? This is type 1, type 2, type 3, and I think this is type 6. I'm going to select type 2 because that's the fun one. We're going to keep a historic record of all the changes that happen. I can build this. I can create and load it. I need to tell it what columns I want to track on. If you notice, the business key carries over from the stage table. We're going to track, in this case, I'll just track all of the geographic values. I click OK. It runs it. It populates it. And now I've got a fully functional type 2 dimension created from that table I had in Snowflake, all in about 60 or 90 seconds. So I can see the effective start date and end date for each of these. If I had updated data, it would insert new records and things like that. Let me show you one more aspect, and then we'll get to the Q&A. Again, there is a Q&A button at the bottom. Under reporting, under documentation, I can create documentation for this. Let me do one more thing very quickly. Let me go look at here, and I can show you that I can add documentation here at the table level, at the row level. It's nice that I can, for example, on a fact table, put in things like what do the measurements mean? Is this quarts or gallons? Is this kilograms or pounds? I can certainly add that in there as well. So create documentation. We're creating this as an HTML file that can be shared. We're creating two types of documentation, one for the end users, one for the analysts. Let me drag this over here. Popped up on the other screen. So I've got user documentation that includes my new table I just created. If you notice all these comments, where do those come from? Those were extended properties in SQL. And what WhereScape did through data warehouse automation is it loaded those into the metadata at the load table, and those flowed downstream from the load table to the stage table, the dimension. I mentioned rapid prototyping. If someone wants to change, add calculated columns, do any kind of normalization, denormalization, any type of conversion. Here's my comments I typed in. That's all very quick. The other thing is technical documentation. I've got that. Here's my new dimension. This is not part of a star schema because I didn't add that yet, but here's my trackback diagram showing where this data came from. This is, again, an HTML file, so I can create this documentation and then put it on a file server. The analysts, the developers, everyone can come in and see this documentation that answers a ton of questions and saves a lot of messages and things like that. Kent, have you seen?
Yeah, that's great.
Yeah, it's kind of the unsung hero. I always describe documentation as the face of a project where someone runs around and grabs all the Post-it notes and types it in Word.
And nobody ever actually does that.
Yeah.
But the fact that you can do the drill through and drill back on it and generate it that quickly is awesome. That was one of the impressive features that WhereScape's had since I was first introduced to it. That because nobody was ever building time into a project to document it. You know, if we did build it using an ER diagram, we had that. But it is, you got to put the effort in. Right, put in the metadata. If it doesn't exist already, then you have the opportunity to go in there and put in column comments and definitions and things like that, so that you can make that end user documentation very accessible and useful to a business analyst who's trying to figure out what do you got in your data warehouse and where did it come from.
And as I said, something as simple as they've got a number in a fact table. Is that gallons? Is that quarts? Is that liters? Those kinds of questions can be answered in the documentation. Yeah, I went through that very, very quickly. I probably spoke very, very quickly too. I've been accused of that in the past, just because I wanted to show you that I just generated, I don't know, 800 lines of Python code and NoSQL. I created tables. I created functions that was moving data from SQL Server into a load table, a stage table, and then a fully functional type 2 dimension. And now it's documented as well. That's the example of the power of data warehouse automation. And if Kent had done the same thing, the code would look exactly the same. There's enough flexibility in there that if he had additional requirements, he could modify the templates that generate the Python code. He could add his own controls. There's a lot. Also, I skipped over a lot of the default options. There's a lot of things available there. So Kent, I will jump us into the Q&A. We've got a few minutes left until the top of the hour. Can you please elucidate, and this is a good question for you, Kent, can you please elucidate and elaborate further what designing data warehouses from data catalog actually means? So if you've got data catalog, I don't know if this is current state or future state he's asking about, but
well, you mentioned that in, I think level 3, that you could do some design from a data catalog. So that's assuming that there's a data catalog out there. Is it level 3? Maybe it was, I know it was in one of those. That's where it came up. Yeah. Yeah, that one. Assuming that you have basically a data dictionary of some sort, because if that information is there, that includes things like foreign keys, primary keys, data profiling information, and all of that is something that is actually the WhereScape tool is capable of doing that, of reading these things. But you have to have at least that baseline of information in order to try to move forward with a data warehouse design. So in WhereScape in particular, if you pick that you want to use Data Vault, if there's information there, it can kind of guess what would be the business key, but it still lets you pick what the business key is. But when you're loading the data up, if the relationships are there in the data catalog, then it can infer a lot of things for joins and things like that. So it's very important. The higher level automation you want to go, the more important it is that metadata already exists somewhere, that there's valid metadata supporting what your data infrastructure looks like.
Yeah, I would say that right now with 3D, our design tool, we're not going to automatically generate a design, but we can certainly assist in generating the design. If there's attributes in the data catalog that describe PII, secure data that maybe there's other attributes, you can certainly assign those attributes in our analysis of the source system, and then our rules-based system can take those attributes into account when it generates the design.
And really, what you just showed, I mean, you're looking at the data, we used to call it a data dictionary, but really the catalog in the database, and building stage tables and load tables automatically off of that, and adding in certain metadata columns, right? And that's allowing you to design these things way faster, because it is just pulling in the existing information from the source system in order to kind of get you started.
A couple more quick questions. This is just a generic question. I can answer this one. What's the best tech for a data foundation, data lake, data vault, third normal form for a large complex organization? So as a former consultant, I can say it depends.
I would, of course, recommend Data Vault for large complex organizations because of the characteristics of a Data Vault. Now, a Data Vault could be the design methodology you use to build your data lake or data lake house. So, one is more of a concept. Data lake house, data warehouse are definitional concepts. Data Vault, their normal form, dimensional modeling are our design and modeling techniques and methodologies. I think that, having done it for 2 decades now, is Data Vault has proven to be probably the most sustainable and easiest to deal with as your landscape grows and changes over time. It's a lot easier to make adjustments to a Data Vault model than it is a third normal form or a pure star schema dimensional model. Though you may want star schema dimensional models, as Patrick was just showing, on the reporting end, and that's part of the Data Vault methodology. It has a staging area, the central foundational enterprise data warehouse using the Data Vault techniques, and then a reporting layer that is usually designed in using dimensional models, just because the tools support that better.
All right. Hey, we're a minute past the top of the hour. There was a question about metadata that's available in our builder tool and our design tool, and I'll just say that it is wide open. WhereScape is wide open. We certainly have customers and partners that are analyzing the metadata directly. We really discourage people from changing that data. But as far as reading it to make sure people are following design standards, making sure there aren't orphan tables and things like that, that's all available. Kent, I say this every time that right before we begin, I think, what are we going to talk about for the next hour? And then before I know it, the hour's up.
Yep.
So it's been a pleasure. I enjoy it. Enjoy yourself in New York. And
right.
I'll thank you. I'll thank everyone for joining us and attending. If you have any questions, feel free to follow up with us at moreinfo@wherescape.com. If you liked what you saw and you want to see a larger demo, see what we're fully capable of, again, you saw the proverbial tip of the iceberg at wherescape.com. You can certainly request a demo. Kent, again, thank you very much. It's always a pleasure. And I will tell you, until all of the attendees, thank you and enjoy the rest of your day.
So long, everybody.
All right, Kent, I will see you in Stowe.
Yes. See you there.
All right. Bye-bye.
Bye-bye.